Hello and welcome to Learn Data. It's great to have you on this channel. I'm Nilesh, and in this video we are going to look at another application of data science, and this time we'll be talking about sound, and specifically we'll talk about the traffic sound. We'll try to look at an example of how we can classify street noise in a suburb. So let's take a listen to this short clip. So as you can hear, it's a busy street, and there's a bike honking sound, there's dog barking sound, there's the bike, and there's the car passing by. So to for this particular project, what I've done is looked at the noise of vehicles that are passing in front of me. So let's say I'm an observer sitting right here, and there is a bike that's coming in from the left. As it comes closer to me, the sound increases in volume, and then as it goes by, the sound would decrease. So if you look at the waveform, so you have amplitude on y-axis and time on x-axis, it'll look something like this, with height is much larger in the middle of the curve, and it narrows down as we go toward the edges of the plot. So uh, this is for the bike, and then what I've done is I've recorded sounds for car in the same fashion, and then a scooter and dogs, as well as the horn of either from the bikes or any of the vehicles. So in overall, I've recorded around 2 hours of street audio, and then from that long segment of audios, I've clipped the audio specifically for a bike or a horn or a car, scooter, or a dog. And each of those clips would had a time interval between around 2 to 5 seconds, and total number of clips per sample or per vehicle or a dog or the horn was around 30 to 100. So because there was varying number of these uh, events while I was recording the audio. And so now let's look at what the sound looks like. Here, as we can see on the left hand side, we have the amplitude and time for the sound of a bike. Here I'm calling it as a bullet, and in the time domain we can see that these are regular spikes. Now to get features for machine learning from this data, what is done is it's converted into a frequency domain, as we can see here on the right hand side, and here we can see several peaks right near below 1000 frequency. There is a lot of interesting peaks in the plot, and that is helpful while we are training a model. So if you remember previous videos in this series, we looked at how we can use images to train a deep learning model. And in this case, in case of sound, what we are doing is we are converting the audio into an image, and here the image is a spectrogram. And in the spectrogram we can see these bands for each of the type of audio that we record, and this is a melt spectrogram. That's another version of it. We won't go into the details, but just to tell you that these are the type of processing that was done for the audio that was recorded before it was uh, used as an input to a deep learning neural network. here now I have a comparison chart of spectrograms and the time domain signal for each of these 5 classes that we have. And as you can see, in case of the barking of a dog or the horn, we can see that there are clear distinct bands uh, in the spectrogram, and these serve as features to identify that particular sound as compared to other sounds that are coming from the traffic noise. And if you notice, the sounds for the car and in this case the scooter, they look much similar, except there are some more prominent bands on this side, and that's probably because the street that I was recording the sounds on, it was a busy street, but it the speed of the traffic was much slower, as it was between houses, so it was not a highway where the vehicles were passing by. So it was a small street within a locality. And again, there were several challenges. There were other noises of people talking, people closing the door of a car, or there are birds in the sky chirping, and other vehicles that were passing through that I have not included as a class in this video. So with all that information, now let's look at what the process was. We collect the audio file, it's a WAV file, then we label it. So either as a bike, here I'm calling it as a bullet, and car or a dog, horn or a scooter. And then we create the spectrograms, and then those are input to the neural network. And once we have a model trained, we can submit a new unseen waveform to that trained model, and it'll detect if it's either of those 5 classes that we have in this project. So now let's look at this sound. As you've heard it, it's a bullet or a bike sound. And now when we look at the prediction from the model, here we can see that the bullet has the highest probability and probably almost close to 1. So the AI is pretty sure that that sound is coming from a bike and nothing else. Now let's look at this second sound. So that's the horn, and now if we look at again the prediction, we can see that the AI is pretty sure that that sound is for a horn. I've not classified it further to say that if it's a horn coming from a car or a scooter or a bike. Just said it's a horn, so that made it easier to do this project. Now let's look at this sound. And this was identified as a car where the probability is above 0.8, and the probability for other classes is much lower. And then moving on, now let's hear this sound. That's definitely the dog barking, and that's what the AI also predicts, that that sound is for a dog that's barking. Moving on, now let's hear this. So that sound was for a scooter, and it was able to predict the sound as it was for scooter with probability greater than 0.8. Now I've shown you the results where the predictions were correct. There have also been predictions that were not correct, where the sounds were so close that it even for me it was difficult to separate or identify if it was a bike or if it was a scooter. So those are not included here. But I hope these results give you an intuition of how we can use AI to identify or classify sound from different sources. And this could be really helpful in various situations where there is no access to imaging. For example, if we are trying to identify the species of birds in a forest area, then it's much easier to kind of go ahead and record sounds, chirping sounds of the birds, and then analyze them using the methods such as this to kind of classify what types of birds are there in that particular locality. So you don't have to go ahead and take pictures of each of those birds. Just audio will be sufficient for kind of finding the species of birds that are there. I hope you enjoyed this video. Please like, share, and subscribe. And if you have any comments or suggestions, please post them in the comment section below. Thank you.